as an IT consultant. Today I will talk to you about an experiment I made 1 year ago when I worked for a retail company about deep learning with Keras. It begins with a discussion. So at this time I was a software architect, and I discussed with a consultant, and he talked to me about what it does for the clients around deep learning on images. And I think, okay, maybe we can make some prototypes with our images to be able to classify images of our product, and we prototype also text classification and image search by similarities, and we do it in 3 days. So first, let's talk about Keras and classification. So, for example, you have a bottle of wine. It has some characteristics: alcohol, ashes, color, magnesium. It is what we call features on machine learning. And you want to classify it, for example, to classify by producer, so by wine producer. So you will put all those features of all your bottles in a machine learning algorithm that we call a neural network. For example, if you want to make deep learning to predict producer, and then what we want is the algorithm to predict which producers produce the bottle of wine based on the characteristic of it, so based on its features. So we'll use a neural network. Neural network is a web of neurons interconnected by edges. And in a neural network, you have multiple layers of neurons. Okay, and you will use all these neurons and all these edges to classify and to make some computations step by steps. So. What is a neuron? A neuron, it's a node inside the web, inside the network, and you have input to a neurons, and you have one output. So you have multiple inputs, one output. On the edge of a neuron, you have weight. On the neuron itself, you have a bias, and the output of a neuron, it's a function. Okay. Then you will train the network, so you will vary the weight and the edges to train it to find different outputs, and your network will evaluate itself based on validation data. So you put your data inside your network. It varies the weight, the bias to find different outputs, different functions, and it evaluates which function is best on each neurons, based on the cost, the difference between the validation and the validation that is the reality and the output. So, do you want me to show you the math or the code? The code. Thank you, because I was not able to show you the math. Okay, I just passed 3 days on deep learning, so I'm a newbie on deep learnings. Okay, so we'll classify some wine with Keras. Keras, it's a high-level library based on TensorFlow. This is now shipped with TensorFlow, but you can use it with different backends. And we create what we call the multi-layer perceptron with Keras. Sorry. So we will have one input layer with 13 nodes. So this is a certain characteristic on my bottle of wine. One hidden layer with 16 neurons, and one output layer with 3 nodes of output. This will be my 3 wine producers. Okay? So this is the code. It's easy. So this is Python. So first we create 3 layers. We use dense layer, and we define the input layer and the first hidden layer in the same line, in fact. Then we add another layer. This is the output layer. Then we will define activation functions. So the function that will be the output of the neuron. We use ReLU for rectified linear unit. This is a function that will rectify the input data. And we use softmax for the output layer, because for softmax it's one algorithm be used for classification. Okay. Then we will tell the network how it will evaluate itself. We say by accuracy, so it will use the cost between the difference between the reality and the output. Then we fit. We train the layer. So we put we give the layer the input, an output target. Then we say, okay, iterate 200 of times in inside the network by with the variation of weights and bias, and use 20% of the data to validate yourself. Okay, this is what this code does. So, with a bottle of wine with 16 characteristics, it's easy. But when we want to categorize images, it's a little more complex, because an image is this. An image is not 13 characteristics. It's a lot of pixels. So we have different steps in a neural network to categorize image. The first step is what we call convolution. Basically, what it means is that you split your image in small parts, what we call a tile, and each tile contains some part of the adjacent tile. Okay, so basically, this is this kind of representation. Then on each tile, you will feed it inside a neural network, a small neural network. So if I have 100 tiles, I will have 100 little neural network that will be able to categorize the image, this part of the image, for example, to know if there is a clock inside it or not. Then, as all this is a lot of data, we will use a type of algorithm that we'll call downsampling. We use a max pooling algorithm. Downsampling, it's just you will reduce the size of the data, like reduce the image, but not really, because the max pooling algorithm will focus on the specificities of the images. It's more or less like noise reduction. So if you have a network that you train to recognize certain shape, the downsampling algorithm should keep the shape but drop the colors. Okay, it's really schematic, but yeah, it's kind of. Then you will have a last layer that will make the final prediction. Okay, and this will be close to the layer that we define first with a bottle of wine. In the reality, it's more complex than this. To achieve a good classification on images, we use complex neural network, what we call deep convolutionary network. When we use multiple layers of convolution, max pooling, and recurrent neural network. So, for example, this one is able to predict 1,000 categories with a good accuracy, and it uses two convolutional network, two max pooling network layer, three convolutional layer, and at the end two recurrent neural network to be able to categorize images. Okay, so there is multiple networks that are linked, the one after the other. So based on this, I make some proof of concepts for the retail company I work on. One is product image classification. The idea is to be able to classify an image not on 1,000 categories, but on the categories of my product catalog. For example, to know if it's a shirt, a pants, to know if it's sport clothes, stuff like this. Okay. The principle is to use a pre-trained deep learning model. Usually, you will not create your own deep learning model like I show you on the bottle of wine example. You use pre-trained model and you will customize it. Then we will recalculate the last layer, because in fact, on a deep neural network like I show you, this is only the last layer that makes the prediction, so the last layer that makes the classification. So you can just reuse all the previous layer and train the last layer with your own classification. Okay, we use a very small data set of images, approximately 2% of the product images we have, and we keep 40% for validation, and we have a success rate of more than 95%. So image classification, it's really something that works really well. We tested with images of clouds taken randomly, and it works. Okay, it was really simple. This is the code. So here we load a pre-trained network. We call this is a VGG16. It's a really well-known neural network for image classification. Then this code will compute the features of the training data. So it will scan a directory for all images and compute the features of the images based on the step I'll talk about. So convolution, max pooling, and recurrent neural network. Then we compute also the features of the validation data. And we create a new layer, okay? A layer that we will use with an activation type of sigmoid. This is for classification. We train this new layer only with our features. So normally, this new layer will be able to categorize on our own category because we'll train it for this. At the end, we'll create the final model. So again, we load VGG16 without the last layer. Then we create a final model with the base part of VGG16, then our trained last layer. And we will be able to make a prediction with it. Okay. So this successfully classify the left images as a church and the right as a paint. Good. So image classification, it's really easy. Then we try to implement a product search by images because it's really what we wanted to do, to be able to have on our website, selling website, just a way to search by similarities, similar images. The principle is not different from classification. So we use a predefined neural network, it's the same. We remove the last layer because we don't want to have a classification, but we use this neural network to index the entire image set. So like when you index texts, except we index images with the neural network. So it gives us features, so matrix numbers that represent our image, our product images. Then when we have this index, a search by image will just consist of indexing the image to search, so compute its features, then browse all images, so our index, and search for the top 10 that are mathematically closest. We use the cosinus of the matrices. There is some other way to find which are. There is some other computation that can be made, but we choose the cosinus of matrices. This is the code. Okay, so we load the pre-trained model. We pre-calculate the features of each images, so it's really close to what we did for image classification. And then when we want to search for similarities, we calculate the features of all of the images to search. Then we compare with the index based on the cosinus. Okay, so the results, left the inputs, right the results. So when we use an image from the catalog, it works well. Okay, it's from our own catalog, so it's what's expected. It works well for shape. This is shape, okay. This is color, so it gives good recommendation. When we start using random images, we have some surprises. Like on the bottom right, maybe there is an overfitting on the face. We don't know. Here, I'm pretty sure there is some overfitting on the silhouette. Overfitting, it means that the algorithm use too much importance for something, so too much importance for the silhouette. And here, the background color, certainly. So this is only the beginning of the world. So if we want really to have a good search by similarities, there is a lot of work that needs to be done. Like, for example, industrialization of the image, to have all image without a mannequin, having a more complex algorithm, and maybe pre-select some categories. It's pre-categorization of the image before searching it to search only on the sport part on the catalog. It's what Surround does. Okay, thank you. Time is up, but you can ask me question. Just comes here or just outside. Thank you.